Good afternoon, class. Hope you're all doing well. Me, I'm fine. I hope you're keeping safe. So today's class on fuzzy logic. I want us to start using the Anaconda platform, with which we are going to write our fuzzy logic algorithms and also our neural network algorithms, because now it is the time for us to be looking at fuzzy logic and neural networks and everything. Now we are diverging straight into what we call the application part, because I remember I said that this work shall do it theoretically. We have covered the set theory, the fuzzy inference engine. Now today we want to look at the fuzzy logic system. There's a few code which I had sent to you. I wanted you to implement it and see the way that code behaves. But I realized that I had not shown some few aspects which I want to show today. The first thing is how to use the Anaconda platform to write AI algorithms, AI and machine learning algorithms, because that's what we shall be doing. And secondly would be how to install or update missing libraries and packages in Anaconda. So that would be my thing today. And also thirdly, if I have the time, would be to introduce the concept of artificial neural networks or neural networks. Concept of neural networks. So that's what we are looking at today. So welcome to this class. So I believe by now every one of you must have downloaded the Anaconda prompt. If not, I would just show you where to go and get that prompt. It's quite easy. You just go to Google or you just write Anaconda, and it will open for you the Anaconda. It will open for you the search page, and then you just click the Anaconda world's most popular data science tool, because Anaconda is purely for data science and cloud breaking research and everything. And then we go to download. It's not that big. I believe Anaconda is not that big. So you go to product. I think you go for individual edition, because that's what you usually do. You usually go for the individual edition. Individual edition is one which you usually use in your own person, and then you come and download. Okay, then you can download. So once you download, then you install. You follow the normal prompts, and then after you've installed, then it will open up for you the Anaconda Navigator. So most of the things which shall be accessing through the Anaconda Navigator. Now the Anaconda Navigator is we call it a one-stop shop for everything dealing with data science, because I know the best two languages which are used for data science. One is Python, which you are learning. The other one is called R language, or R. It's usually found in R Studio, which is also another very good language. If you want to learn data science, you can learn using R. And funny thing is, I find R to have a lot of more packages than Python sometimes, because for us, I see Python, you sometimes have to customize or to build your own functions, your own machine learning functions. But today we are going to look at the work which I've given, which is found here in your fuzzy logic course. I'd given that work, I think, sometimes last week. And I'm sorry we have not been able to have an online session for a long time due to the issue of, first of all, the exams. And then after the exams, now we had the issue with people not being able to access the big blue button and everything. And now we have now the issue of the big blue button not being able to do what? Not being able to the big blue button not being able to handle those the concurrent sessions. And that's why for me, most of my work has been a bit, I just send the work and then I hope that you guys will be able to do the work. Now, today we want to look at the best example or problem which is in use when you're looking at the fuzzy logic implementation. And the best one is what you usually call the plot tipping problem. The tipping problem. Now, the tipping problem is basically a case scenario which is used to explain how fuzzy logic works. And remember, I said that fuzzy logic deals with uncertainty. It deals with uncertainty, and it gives you a possible list of scenarios with which to choose from. So with this tipping problem, you're actually looking at a problem whereby you have gone to a restaurant and you have ordered some meal, and then this system is supposed to decide for you whether to tip the waiter based on the food quality, the service given. I think there are 3 parameters. There was food, and then there was I think there was food, and then there was service. Yeah, so there's that aspect of tipping problems. Yeah, so there are those inputs which you are supposed to have, and also the one which you are supposed to look at and be able to get the aspect of this tipping problem. So the tipping problem, as I showed, the place where you can be able to get this tipping problem, or this is the first source. The second source would be if you go to GitHub. Usually, I told you that the best repository where you can find material, even apps which you want to go and implement, you just go and search on GitHub, and GitHub has a host of places, a host of things which you can be able to find and be able to implement, dependent on the language which you want to use. It's not only about Python, but we have programs for Android. We have a lot of things there which you can be able to implement. Now we have the fuzzy logic, the tipping problem. And then we have, so this one is the tipping problem, which I usually like looking at. I think it's nearly the same like the other one. And this guy, this one actually had, there's this which he can be able to use, but this one I believe it's a bit of it's a bit different from what we have, the tipping problem. So let me just fuzzy logic. You can just search for fuzzy logic. It has those scenarios which you could be able to pick from, and then you come and look for Jupyter Notebook. That is how we usually use this thing. And then there are a lot of resources here which you can look at and be able to look at how fuzzy logic has been implemented and how it has been in use. So this is a good example of fuzzy logic. So we need to install matplotlib and everything, and then the code is usually, these are CSV. So this one is the fuzzy IPane. Python usually, Jupyter Notebook has this what we call extension when you save a file using that extension. So this is an example of a Python, of a programming for fuzzy logic, falsification and rules and everything, which this guy was able to bring up. And now the thing with this, you can copy this code in Python and in Jupyter Notebook and be able to see how it behaves. So for today, the first thing I want to show you is, let's say, for me, I know I have installed the Anaconda Navigator. So this is the Anaconda Navigator. So once it comes on, there's usually the CMD, Exceed, the Jupyter Lab, the Jupyter Notebook on the orange, which is usually there. Then we have PowerShell, and then we have Spider. Then we have Visual Studio Code. With yours, it will not be launched. It will rate install, because me had already launched mine. So install. Now you see it has these tools which you can use. You can use GlueViz, you can use RStudio, or you can use Orange. Orange is also another good tool which you can use when you're looking at data mining. Now, the good thing with Orange is that you do not need to write the algorithms. The algorithms like, for example, neural networks, random forest, support vector machines, they have already been coded. So your thing is just to connect it to your data source and be able to see how that data source will behave. That is the good thing with Orange. But now our main aspect is to look at Jupyter Notebook and know how it is done. Now, the first thing which we need to really be careful with is, first of all, to know if most of these libraries are present. Now, we come and launch Jupyter Notebook. Jupyter Notebook is quite easy to use. Actually, I prefer it more than Spider. Spider is just an integrated development environment, while Jupyter Notebook is web-based interactive computing, and it enables you to edit and run documents while describing the data analysis. That's the good thing with Jupyter Notebook. Jupyter Notebook enables you to program and code step by step. So I prefer for Python, when you're learning Python, I prefer even for object-oriented programs, which object-oriented programming to which you're doing, and I believe the lecturer is lecturing you using Python, you could be able to use the Jupyter Notebook, because this Jupyter Notebook is a good and easy tool to use. Now it opens up the home page for you, whereby it shows all the things which you have done. There was some work I was doing on draft set work. That was 3 months ago. By then, I need to go back to this work. I have not yet finished. That's my project, my research work. So it opens up all these things. So let me just create a folder. So let's say I want to create a new, not there. I want to create a new folder. There's a place whereby there's a new folder. Let me create a new folder. And then here it is. So I select it, and then I say rename. And then when it renames, I call it fuzzy logic classwork. So it's not a must you create this folder, but I'm trying to do that so that I can be able to be like have all the work that you shall do here. So all the work that you shall do, I shall be saving it here. So we want to create a new Python file. So you come to new, then you choose Python 3. It will open up for you a new editor where you can be able to start typing the code. Now, when it opens up the new editor for you, the work basically for you is just to purely take that work and be able to look at it and be able to do what, and be able to work your work and be able to do whatever it is that you're doing. Now, the other thing which I want us to do now is we start our coding. We start our coding. Now, with this fuzzy logic, the first thing which we usually do, we have, if we are going to import libraries and files. These libraries and files are really important because they help us with the data analytics that we use. For example, Numpy. If you come and look at what Numpy does, there are things which we'll need to import. There are files or libraries we'll need to import. Which libraries which are important in data analytics. And I believe in the last class, I asked you to look at these libraries. The first one is Numpy. The second one is matplotlib. The other one is skfuzzy. And the fourth one is pandas. So we have to look at what do each of them do. So for example, you just come here and you search. Just come here and you search. Okay. My friend, go back, Ukoju. Yeah. We just come here and we search. We come and we write. The first one is Numpy. So we come and see, what does Numpy do? So Numpy, I believe it's used for scientific computing. So why is Numpy used in Python? So it adds support for programming, multidimensional arrays and matrices along with large collection. Numpy is actually for mathematical functions. Numpy is used for mathematical functions. Okay, so it gives the scientific and engineering things which we want to use. The same, it comes with another one called Skitlan. Skitlan is what we call the scientific scientific kit. This scientific kit contains algorithms, it contains functions which can be used in data analytics. And then matplotlib is used for plotting. Matplotlib is the one which is used for giving the plots and everything, while skfuzzy is used for the fuzzy logic logic. Now, one thing with skfuzzy does not come pre-installed in Anaconda. So what you usually do, we have to look for a way to install the skitfuzzy. It's called skitfuzzy or skfuzzy. It's called the skitfuzzy toolkit. This skitfuzzy, when you install Anaconda, it's not usually there. So the first thing which you have to do is install this skitfuzzy. And the best way to install this skitfuzzy is to install this package with conda run on this. Now, how do you install this package? The best thing, you come to where Anaconda is. I'll open up my Windows. I go to where Anaconda is, and then I go to Anaconda prompt. See where I've gone? I've gone to Anaconda prompt. And then when I'm on Anaconda prompt, for all packages that you'll need to install using Anaconda, or you want to use in what we call in Jupyter, or even in Spider Toolkit, or let's say if you're using the IDE, the idle IDE Python, you'll have to install most of these libraries in command prompt. But for Anaconda, it comes with its own command prompt. So this is where we are going to install the package. So your work is basically just to take this code. You say conda install C4. You just say copy, and then you come here and you say paste, and then you press enter. What it will do, it will search. It will search for where that skitfuzzy is, and then it will install. But I believe for mine, I had already installed it. So if it finds that it's already installed, it will tell me that the condition has already been met, and it will jump to the next thing. So we have to wait for it to install. So the thing is that this installation must be done while you're online. It is really important when you're doing data analytics to be online, to be on the internet, because sometimes you might be writing huge pieces of code, and you'll need to get libraries from libraries which you might need to use in your work. Either libraries like Quad Cloud, we have libraries like ML Extend. We have so many libraries which you might need to use. So it's really important. So this thing will have to search, and then it will have to tell us if the condition has been met. So that's the first thing you always do. You always look at what is in need. If that file is there, then, if that library is there, then there's no need for installing the Anaconda. But if it's not there, then you have to install the package. So the only thing which you do is, the package which you need to install. You see now it's collecting package metadata. Maybe I had not installed it, I don't know, but I believe I had installed it the last time. But it will tell me if it's not there, it will install. If it's there, it will continue on its own. So it has to collect the package metadata. So this is an online repository. So if it's online, it means that you have to be connected to the internet so that you could be able to install these libraries. Now, for fuzzy logic work, which you shall be doing, the skfuzzy, the skitfuzzy is a very important library or package which is necessary for us to run fuzzy logic functions. Why? Because this skitfuzzy package contains all the functions that we shall need to implement in our fuzzy logic work. So that's why we have that skitfuzzy. You have to get that skitfuzzy, what do you call that skitfuzzy? The skitfuzzy package. So I'll wait for it to finish solving the environment, and then we shall get straight to coding. Now, for everything that we'll need to do, we shall be able to get it and find it here. Now, as I said, one thing, it's really important when you're looking at whatever it is that you're going to do, that you be able to know where to get that information from. And I say the best repository which can always help you is github.com. GitHub has all the information that you need, and it will be quite easy to get it. So the next thing which I want us to be doing, which shall be around next week, shall be looking at artificial neural networks, and we shall be able to see how they have been implemented. So we just take a case scenario and you'll see how it has been implemented. And in most cases, Jupyter Notebook. And you can see that a lot of work has been done with the Jupyter Notebook, the artificial neural networks. And they tell us a lot of things, what I'm seeing even a lot of information, which is really important. So we have the tutorials, the introduction, the forward propagation, the back propagation. So the introduction basically takes us to the introduction part and tell us what artificial neural network is. So I think we shall be using this repository, which is really important. We shall be able to get whatever it is that we want to learn here. So you see, with artificial neural networks, you have to use the skitlearn toolkit, which I believe is there. So it's telling me here, will be updated here. So let me just say proceed, yes, and then it will update. It will update. So it is updated specs. So I had already installed the Skit Fuzzy, but these packages keep on being updated. So it is really important to always update your packages. So that you could have the best toolkits which will be there. So it has already been done. So it has already finished. So we have finished installing the SK Fuzzy. Remember, when you're installing packages that are to be used in Python and you have installed Anaconda, you have to install them using the Anaconda prompt. If you have installed idle, then you have to go to the command prompt, CMD, and install from there. But because you have done Anaconda, we install using the Anaconda prompt. You go to start, Anaconda prompt, then you go to where that Skit Fuzzy thing is, the package is, you just type Skit Fuzzy in SK Fuzzy in Anaconda. It will tell you where to install this package, and you just copy that that code. So as you can see, the description of the package, it has tools involving fuzzy logic. Gray logic is pure Python and depends only on Numpy, SkyPy, and NetworkX. They are basically what we call those aspects which you want to use. So now let's go back to our coding, the thing which you wanted to look at and use. So we have our fuzzy logic work. So we have our Untitled Jupyter Notebook here. And I want to share the screen for the Jupyter Notebook. So the first thing which we have to do when we are coding using Python is to import Numpy. The first thing we have to import is import Numpy, the Numpy as NP. So Numpy, we said, is for it is for scientific computing and everything. Now the good thing with Jupyter, I said, is that for each line of code you can run it and see how it behaves. So you run. If there's an issue, it will automatically tell you here that there's an issue. It will debug for you. But now you see, if it writes one, it is okay. The second thing which we need to import is the skfuzz. Import skfuzz as. Is it skfuzz or skfuzzy? Skfuzzy as fuzz. Skfuzzy as fuzz. Then we run. So because you have downloaded the skfuzzy package, I believe it will automatically do what? It will automatically pick the package. And as you can see, because I had installed it and I had updated here, then it will run. But if you have not installed that package, it will not run. It will always tell you that package is missing. So you need to install it from there. The next thing which we need to do is we have to say from skfuzzy import control as control. So this one, you shall see the use of it when we get to it. We import skfuzzy control. Then the next one is to create antecedents and consequence. Remember, we said antecedents and consequence. Antecedents are like things, are precursors to a consequent. A consequent is a consequence. So a thing which leads to a consequence is called antecedent. Remember, that's what we had when we were looking at fuzzy logic. Now, our two antecedents are quality and service, and our consequent is tip. Remember, we are tipping. So we want to tip this waiter. So we are looking at the quality of this, at the quality of the food and the service that was done. So we shall have to have, we just copy that whole line of code. Then we come and place it here, and then we run it and we see. So we are creating these quality, which is antecedent, and service, which is antecedent, and tip. So meaning that dependent on the quality, the rate of quality we give and the rate of service we give, it will relate to us the SIP. And we give the membership values. So these are membership values which you have defined from 0 to 11, and service from 0 to 11, and consequent from 0 to 26 as the tip. Okay, so we have that. So we have to give that the antecedent. So here we are giving it on a scale of 0 to 10, and a scale of 0 to 10, and a scale of 0 to 26. So when I say 0, 11, 1, it means that I start from 1 to 11. When I say 0, 11, 1, I stay 1 from 11. I say 0, 26, I start from 1 to 26. So on a scale of 10, how do I rate quality of that waiter? On a scale of 10, how do I rate service? And on a scale of 25, out of tip. Now this tip will be the consequent of this. Now the next thing which we need to have is membership functions. And remember, we have those membership functions, and membership functions actually tell us the auto membership function. So membership function basically is based on the fuzzy set. The fuzzy set, now we have created our fuzzy sets, and our fuzzy sets are quality and service. So that's our auto membership function is possible with auto MF3 or 5. So we create our auto membership value. Okay, and then the next thing we have to create is custom membership function. Remember, we have that aspect of membership function. So membership function this member we say belong to this certain site. So we have to create those custom membership function so that we could be able to have a range of values, or a range which could be used in our tipping problem to give us the range. So here I'm going to say that the tip low, I'll have to give it from 0 to 13. The tip medium, I have to give it from 13 to 25. And then the tip high, I have to give it from 0 to 13, the tip low to 13. Tip low is 0 to 0. Tip medium is 0 to 13. So tip low is anything that is 0, that is low. Tip medium is anything that is 13, between 0 and 13, that is medium. And tip high is anything that is from 13 and above. So that's the custom membership function. Remember, like when we are looking at the set, whereby I say that X is a what? X is a universal member, and these are the membership function whereby we have X is there, and then you have an X naught with membership function 0.4, 0.5, 0.6. So that's what I mean. Like for low now, it means that for low, anything between 0 and 0. So it can be 0.5, 0.1, that is low. Medium is anything from 13. Anything from 13. Okay, anything that is 0. So when I say medium, it's anything from 1 up to 13. When I say high, it's anything from 14 up to 25. So that's what it means. So we get those membership functions. So membership functions enable us to group. Like for example, I'll give you a very good example of a membership function. When you guys do your exam, there are those who perform well, there are those who perform in the middle, and there are those who fail. So membership function can be like exam, pass, those who are bright, those who are what we call bright, and then those who are a bit bright, and then those who are not so bright. We cannot call people daft. So we have to do that. So it's like that. So we have to customize membership functions with a familiar, or interactively with a familiar Pythonic API. So it can be like that. So these are Pythonic API. So we trim, these are trim. So that's why we have that trim membership function. Try membership function, try membership function, try membership function. So 3. So we have to give that range. So we have created a custom membership function. Now we want to see, we can look at a view, how that view looks like with the membership function. So we can look at that, and it will be able to display Now you see it has been able to display. So with the membership function, it shows you average is between here and good and, poor and good. Now you see anything that is between 0 and 5, that is average. Anything that is beyond 5 and 10, that is good. Now, anything that is below here, that is poor. You see, this one is poor, this one is average, this one is good, and also this one is average in between them. So we are able to view those membership functions. And also for service, you are able to view, let's say service view. You can be able to see the membership function. Now, this is what we call what? What is this triangle called? Remember, we had trapezoidal, Gaussian. So what type of membership function is this? I would like you to tell me in your own assumption. Now we have that membership function. So we're able to get that service. But now we are not, that is not our main, and also for the tip, we can also be able to view for the tip. But this is not our main aim. Our main aim is to create a system which can be able to enable us to think outside the box of when should we tip or not. So after that, we come in and we create our fuzzy rules. Now, we have to make these triangles that we have useful. So the only way we can be able to make useful is to apply rules to these custom built membership functions we have. And remember, we have if antecedent is this, then consequent is this. So we have to apply rules. So we have to apply rules, and we have rules. So we have 3 rules. So the 3 rules, the first one is if food is poor or the service is poor, then the tip will be low. Second is the service is average and food is services, the average, then the tip will be medium. If food is good or service is good, then the tip will be high. So those are the 3 rules we want to apply in our case. And we can apply them and then we view how they are. So you see rule 1, control. That's why we have the control here. Import control as control. So control will control how these membership functions will behave, and it will go and be able to detect if this guy tells me that the quality of the food is low and the service is poor, then the tip will be low. If the service is medium, then the tip will be medium. If the food is good, then the food will be high. So let's look at the rules. So these are the rules. So rules have been using the matplotlib. I've forgotten, okay, but it will plot. It has already plotted those rules. So these rules, the way they are, it's not easy to understand them as to what they do. So these are the rules, the way they have been able to be depicted. So the rules will go like that. Let me try and see if I can run again, if it will give me a different, yeah, it will give me a different. So for each rule, the way you run it, it will give you a different plot. As you can see, the plots change. The plots do change for each of the rules because it's a fuzzy logic system. It's a fuzzy logic system, and the rules should change depending on that fuzzy logic system. So the rules change depending on the code that you have. So we have created our rules. What is the next thing that we need to create? So we have our rules. So the next thing, we need to create a simple system, which we call the control system creation and simulation. Now, this will enable us to simulate, this fuzzy logic system is a simulation. So you want to simulate this environment to see how this fuzzy logic system will behave, okay? So we have to create a control system simulation. And this control system simulation will be able to control the tipping on how it is. How they are being employed. So we apply this function here, tipping control. So we create a method, we call it tipping control, which is based on the control system, based on rule 1, rule 2, and rule 3. And then we come and create a simulation. So we need to create a simulation here. So this one, if I may, so this one is a control system. So if I may put it like this. So to write write a comment, we usually put hash. So this is simply create a control system. So this is a control system called tipping. And then we need to create, we need to create another system to simulate this control system. So creating a system to control or to simulate this control system, not to control, to simulate. To simulate this control system. And so we call it tipping. This system, we call it tipping.control. So a control simulation system. This is the control. So we are creating this control system simulation to control this control system we are having here. So it has created. And then so this is for our own system. Now we can simulate. Now we see we have a control system, then we have a system to simulate the control system. Remember, the control system, we need to simulate these rules. We have already created the rules here. So we need to have an environment to simulate these rules which have been created here. From these rules now, after I've simulated, then you can be able to see how our fuzzy logic system will behave. So now we can simulate by specifying the inputs and calling the compute method. So this is what we can do. Suppose we rate it. So this is a function. This is a what we call. So now we can simulate and by simplifying the inputs and calling the compute method. Suppose we rate quality at 6.5 out of 10 and service at 9.8 out of 10. So we can see how it behaves. So we can have this aspect, tipping.input. So we have to use tipping.input. So remember, we have this control. This is our simulating system. So we say tipping.input. We are inputting into the quality and the service to be able to get the values. And then we come and we compute. Now, when you're computing, you're actually now simulating the system. When you're computing, you're actually simulating the system. Now it has finished computing and simulated the values. Now, the thing now we need to do is we have to visualize. Now we visualize the results. Visualize the results after computing or executing the simulation system. So we visualize the results after computing or executing the simulation system. And we just use the print and tip view. So we print. So we print the print tipping.output. So we have to input the values, then we have to output and see how they behave. So there's a missing parenthesis. Okay. Yeah, it's supposed to be like that. Print. Let me check this one. Let me check if it will Bali. Sometimes these things are really funny. So let's run and see how it behaves. Yeah. So I've forgotten to put this. So it's a function. Remember, it's a function. It's a predefined function. So it will be able to put like that. So they visualize the results. So because the service, the quality we had put it at 6.5 and the service at 9.8 out of 10, then it means that it is of high what? Quality. So that's how the fuzzy logic believes. And that is how the computation will give us. It will give us 19.8. So it is actually here. It's around 20. Remember, our maximum is 20. From here, our maximum is 20. The consequent is 25. Remember here, the quality you have given it at 6.8 out of 10. And the service, we have given it 9.8 out of 10. Remember, I said the range is 0 to 11, but I start at 1. So that means it's 10. Here is 0 to 11, range is 1. So here, let me just put it here. Range is from 1 to 10. The same here. And here the range is from 1 to 25. 1 to 25. Just that's why the curves here, they all end up, you see here, the range, the qualities are 1 up to 10, service is 1 up to 10, tip is 1 up to 25. So when I'm going to draw the graph, it will have to give me that range at the maximum, which is here, which is 19.8, which is here, which is 20. So we are actually visualizing. So after simulating these rules, this is what we get. That is for a high tip. What about if we change and we give it a low tip? Let's say visualize after computing the simulation. Now here we can, we have a second one. We have a second one whereby we come and say, tip, we put it at 3.5 and service, we put it at 9.8. Let's leave it there. We see, maybe the food was bad, but the service was good. Then we have to visualize. Then you visualize. Let us visualize the way it will be. Now you see where it will be. The service was very low. So it means that my probability of tipping, the amount of tip I might give of the probability, it will be around 15 based on the poor what? Service of food. Let's say now, if both of them were poor, let's say I say 3.5 and then I say this one is 2.5. And then I compute. And then I come here and I say print tip. And you see the graph. As you can see, the graph is low. The graph is low. That's why it's even shaded red. The graph is low. The graph is low. The graph is very low. So the tip is bad. So this is how fuzzy logic usually behaves. Okay, that is how fuzzy logic behaves. So remember, with this kind of a scenario which we are having here, I've said that first you have to get, you have to do what? You have to get those fuzzy logic. You have to import the libraries. Then you create the antecedents and consequence, and then you create the membership functions, and then you come and do the rules. Then you have to create a control system, which will be simulated by a simulation system, and then now you come and apply those logic that you wanted to look into. So that's how we usually do fuzzy logic. And that is the best example we have, which is called the tipping problem. That's the tipping problem which we have. And that is how we usually use the Jupyter Notebook. It's quite easy to use. And the Jupyter Notebook, I like it because for each line of code you use, you will run it and see whether it will execute or if it has a problem. Like for example, I showed you somewhere whereby it had a problem here, and it was able to tell me by the boss, hapo kuna shida, haujaeka brackets. And then I'm able to put the brackets, and then it was able to finish the simulation. So that is the what? That is the tipping problem which I have. And it's pure and simple to use like that. So I don't know if I will rename it. So I can give it tipping problem example. Problem example. So then we can close it. Once you close it, it will be found there. So it's usually good when you're finished coding, you just shut down that so that it can free up resources in your system so that you could be able to create another file. Now there's another second one which I had. And this second one was from yeah. Okay, where's the ZDS? This second one was about, I had sent it there, was about a talent search show from where? It was about a talent search show from, I think from Korea or something. Yeah, I did from Korea or something. And I think this one is here. And remember, guys, kindly do these practices. It's really important. Yeah, the Indonesian idle fuzzy logic IPNB. And this one is for Indonesia. This one was an example. It's also on GitHub. I usually say that most of these examples we find it here in GitHub. So it's still the same, as you can see, the same things which are needed to be imported are the ones which are being imported. Okay, so where is this thing? Okay, you're Indonesian. So I finished with the tipping. Now let me come to this Indonesian. So these are free code which are there. So the thing which you do, I usually tell my students, it is quite easy for you to develop your own machine learning code. You just pick it and you understand how it behaves, and then you try and tweak it on your own. So here we import the same import things which you needed to import. Import, and you put them here. So it's quite easy. So we have that, we import Numpy as NP, then import escape fuzzy as fuzz, then import that one as that. Then we create our antecedents. So our antecedents here, and we have a consequent. Antecedents is voice quality, popularity, and attractiveness, and the consequent is winning chance. So antecedent quality is from 0 to 10, 1 to 10. Popularity is from 1 to 1500. Attractiveness is 1 to 10, and the chance of winning is up to 100. So we have to create our antecedents and consequence. So here we create them. Then we come and we give our membership functions like voice names, popularity levels, voice quality, popularity out on F, and also we have our membership functions which we need to look at, because you are talking about voice quality, so it will be the voice names, popularity level, and then attractive levels. So we run them. We have created them. Then you come and check the winning chance, the membership functions. The membership functions for the winning chance. So we set them. So we have set those membership functions. No chance, we have given it up to 25. Slight, we have given it up to 50. 50-50, you have given it up to 75. Good chance you have given it up to 100, 75 to 100, and most likely you have given it 100. Then we come and we set our, we want to see the views of these membership functions we have had. So we just run it and it will be able to deploy and be able to show us. So it will be able to show us the voice quality, the popularity. Popularity has 4 levels: obscure, not popular, non-celebrity. And attractiveness has very appealing, and average, good looking, very attractive. Winning chance has no chance, slight chance, 50-50, good chance, most likely. So I want you to get the way we are just getting these codes and applying them to our Jupyter notebook so that we could be able to see how these membership functions behave. So we have these membership functions. So here, remember, you had those membership functions. You see voice name, poor, 3. Popularity level, you have obscure, not popular, non-celebrity. Attractiveness, you have very unappealing, and average, good looking, very attractive. Then we come and set the winning chance. No chance, light chance, 50 chance, good chance, not most likely. So here we have 5 options which we need to choose from. So we are not sure who of these contestants will behave. So here we come to the next part. To have set our membership functions, we set the rules. We set the rules. Then we run. I believe it will be able to plot. So we are plotting the rules for all the things which we are supposed to have. So we have the rules which we have rule 1, rule 2, rule 3. Okay, so we have, these are the rules which we have. These are how the rules are interconnected to one another. Okay, they are just a bunch of nodes. Now these are the nodes which we shall be simulating. Okay, remember, like the other one which we created our nodes, now we shall go and simulate those nodes. So we have that thing. Now the next thing which we have is now to create our control system, our inputs. Now we have to have our inputs. So inputs, basically, these are the people who we are going to have in this in this competition. So we have to input our inputs, and then we have to create our control system. So here we have our winning control system, control simulation, which is winning. And then we have to print the chances of winning for each of those contestants. So we have 4 contestants. So we try and see the winning chance of each of these contestants. So as you can see, the winning chance are as given. So here we give the values. So like the first one is Ziva, voice quality is 9.8, Instagram followers 10,000, 9.9. So the popularity is based on Instagram followers. Instagram followers, Instagram followers, Instagram followers. So like Saif Abubakar, the chances of him winning are less. Chances of him winning are very less. So that is what we call the Indonesian, the Indonesian, what do we call the Indonesian chance which we had. Now there's something which I want to look at. How do we portray? How do we see like for the tipping problem, how will the graphs look like? The way we had our membership function, then we had the graphs. So print. So we have to do the print. So let me just take that. So print tipping.output. What was tipping.output? So we have tipping control, tipping input, tipping. Oh, so we have tip.view. Print tipping.output. Okay. Is it tipping? It's not tipping, it's winning. Winning.output. Winning. So here we change to winning.output dot not tip but winning. Winning. Then here we view. What was the view? Is it tip.view? Why is it tip.view? Tip.view. Oh, yeah, tip.view, service.view. So it will be something here. We did call it winning chance.view. So this one is winning chance.view. Theme, we say the simulation which we are trying to see. Oh, simulation. Simulation is tipping. We call it tipping.control. So what is the control? Winning.control. Okay, what was it? It was called tipping control, tipping. So there was winning control, winning. So it is winning. So that's the simulation you want to check. Let me check if it will body. So this one, winning. So winning.output. Okay, it's capital. So let's say participants. Okay, so let me debug. So tipping.output. Let me check here. Tip quality, tip.view, tipping control, tipping, tip print visualization, tipping dot input. So we have tipping control, tipping dot input, tipping. So winning, how did I write that winning? Winning control, is it winning control? Trying to be a tip. Tipping dot output, winning dot output, winning control. Let's check tipping control, participants in participants, winning control, rules here, true, winning, because winning control system, tipping control, yeah, tipping control, tipping dot control, tipping dot output, tip. How did they call it here? Tip. How did they call it here? Winning. Winning chance. Just call it winning chance. Let me see how it will behave. I have winning chance. I have to get, because I have to remember the membership function that was put there. So that is now how we get the winning chance for each of these contestants. So the winning chance, slightly winning. Now you see, it is been able to show Abu Bakr is here, then the other one is here, then the other one will be above the winning chance. So dependent on how you set the values, we will get the chance of this guy winning, simulation winning. So we have to get the simulation for each of these contestants. So that is how we are able to plot the fuzzy logic systems, and now we are also able to plot these other objections, or these other objectives of these fuzzy logic systems which we are actually looking at. So that one finishes my first aspect for the day, which was to talk about the fuzzy logic and how it is applied. I've shown you how to apply it in the two problems, the tipping, and I've shown you how to apply it in this what we call the Indonesian the winning chance, or let me just call it the winning chance. Okay, let me just call it the winning chance. Now let's go to, we have finished now the part of fuzzy logic, which is which was the biggest part which we wanted to look at. Now I want to talk about what do you call this? I want to talk about thing we call artificial neural networks. Artificial neural networks. So what are neural networks? Neural networks are basically things that actually mimic the working of a human brain, and they help us simulate a lot of scenarios which we have and which we can be able to actually use and be able to get to use in our day-to-day life. So that's what neural networks is all about. And they mimic the firing of neurons inside a brain. So that's why it's called artificial neural networks. They mimic the firing of neurons within a brain. Now, in artificial neural networks, we shall look at key things: the way it propagates the neurons, and the method it uses. It uses two methods. It uses forward propagation and back propagation. Now, for firing the neurons, it uses forward propagation, and for giving the thinking, or for thinking out loud, or the way it gives us the way the neural network shall give us or it shall perceive whatever it is that it needs to perceive, it will perceive through the back propagation. You have forward propagation and then you have back propagation. So those are the two most important methods that are used in a neural network. So forward propagation and back propagation. So that's what we shall use in our neural network, and then we shall be able to understand what each one of these does in essence, what it usually does in machine learning. So I'm looking for a very good repository for you guys to go and look at in the meantime, so that we can come and we can check on the aspect of neural networks. Come and check on the aspect of neural networks in some time back. So we have these things that we'll use. Then we have multi-layer perceptron. So another name for a neural network is also called multi-layer perceptron. So we have one, notebooks on regression and multi-layer perceptron. So we have linear regression resources, check resources, and then we have the CSVs which we shall be using. So that's what neural networks are always there for. They help us to do, they help us to think like the way a human brain thinks. That's why they're called neural networks. And they are quite, they actually, if I would say that AI is usually based, a lot of the algorithms that have been done are usually based on artificial neural networks. Now we have artificial neural networks, and then we have another sub-branch, which is nowadays very good, which is newer. It's called deep learning or deep neural networks. So we have artificial neural networks, and then we have deep neural networks. So deep neural networks are an advancement of artificial neural networks. So one thing we have to understand with artificial neural networks is understand the layout or the architecture, and then we understand the algorithms that have been in use. We have talked about two. We have forward propagation, and then you have back propagation. Then we have another one which is used in making the perception, the thinking. It's called gradient descent. So that's what we shall be looking at. And that's what we shall be understanding when you're looking at artificial neural networks. So I believe that that shall be in the next class, which we shall have. I shall upload the notes just today so that we can be able to understand how these things usually work. So by next week, I shall add some few work and research a case scenario whereby I'll expect you to apply it using both fuzzy logic and artificial neural network. So thank you and have a blessed day. Thank you.